Hello and welcome back to Calculus 1, section 3.5 on derivatives of trigonometric functions. We have 6 trigonometric functions. We are going to learn 6 derivative shortcuts. Now, as the alternative, let's just learn the derivative of sine going with the limit just because we can, and then realize that actually memorizing those 6 derivative formulas is a life-saving situation. So what does it take to find the derivative of sine x? Well, we can crank the limit, which is what you definitely want to avoid, right? That would be sine of x plus h minus sine of x divided by h, which is the difference quotient for these things. Now, we use the formula for sum of 2 angles, which is sine of x cosine h plus cosine of x sine of h, and then we have minus sine x divided by h. And then we factor out, I'll put the check marks, sine and the sine, we factor that together. So now we have sine x, and then it's times cosine h minus 1, everything divided by h, and then plus in a separate limit, we're going to put limit h goes to 0 of cosine x sine h over h. What happened?
So don't you mean sine h for the first part of it? Limit of h equals 0 sine x you have. You factor out sine h, you just took out.
I factored out sine x, and there is 1 left.
Yeah, so there's another sine x. I'm missing that.
You are the 2 that I put the check marks on are factored out.
Yes.
So from the first one, cosine stays, and from the second one, minus 1 stays for the parenthesis.
Okay, I got it.
When you pull out, and then the middle term is a separate limit now. Now the limit is sending h to 0, which means x is not considered as a variable, it's considered as a constant in the eyes of the limit. So you can kick out sine x and then just have the limit h goes to 0 of cosine h minus 1 divided by h. And then plus over here you can kick cosine x out and have the limit h goes to 0 of sine h over h. And now you are faced with these 2 special limits that you are asked to memorize at first, but then you are in chapter 4 going to learn the way to solve these. So these are special limits. Sine x, the first one is equal to 0, plus cosine x, the second one is equal to 1, so the whole thing is just equal to cosine x. And this is where you finally learn that the derivative of sine is cosine. So the derivative in respect to x of sine x is cosine x, and that is going to be our formula. I should put that actually on the cloud because it is key point for today. Derivative of sine is cosine, and you have the proof, right? We used limit definition for the derivative to show that the derivative of sine is cosine. Now you can use exactly the same process to show that the derivative of cosine x is negative sine x. And that's going to be the second one. And now we got 2 out of 6. 4 to go. So these are our formulas Derivative of sine is cosine. Derivative of cosine is negative sine. Now this will be reinforced eventually in Calculus 2. Again, using a different method to show that the derivative of sine is cosine is going to be really, really cool. Now, before I continue with the other four, I just want to write these formulas in the modified form, which is what you might see most of the time. And that is the derivative of sine ax is a cosine ax, and the derivative of cosine ax is negative a sine ax. Now, I'm going to obviously box this because they will take care of, sine of 3x and so on. So now, if you're asked to find the derivative of sine of 3x, you know it's 3 cosine 3x. So that a is 3 in this situation. Therefore, at the answer, that a gets replaced by 3's, and you have 3 cosine 3x. So most of the problems will have actually those a's. Just like you don't have e to the x that often, but you have e to the 2x, e to the 3x, and so on. Also, if you have, let's say, the derivative of cosine x over 2, right? Well, the a is 1/2. So the answer is negative 1/2 sine x over 2. Because x over 2 is 1/2 times x, so that a becomes 1/2, and you just use 1/2 throughout the problem. So that's the first part. And now the question is, obviously, what are the rest of the derivatives of trig? And the first one that we would like to talk about, obviously, is tangent x. So what would the derivative of tangent be? How would you compute that one? Excellent. The derivative of sine x over cosine x, this is a basic identity where we know that tangent is sine divided by cosine. Great. So now that we have sine divided by cosine, what rule do we get to use to calculate the derivative? Quotient rule from last class. Excellent. So we're going to take the cosine and square it. Then we're going to take cosine and rewrite. Derivative of sine is cosine x minus, copy the sine, and then derivative of cosine is negative sine. So what we get is cosine squared x plus sine squared x divided by cosine squared x. And how much is sine squared plus cosine squared? 1. That is what we call the basic Pythagorean identity. Sine squared plus cosine squared is 1. So 1 divided by cosine squared x. And now what's 1 divided by cosine? That 1. Good. So this becomes secant squared x, giving us the formula that we want. And that is that the derivative in respect to x of tangent x is equal to secant squared x. And this one is going on a cloud. Cool beans. Now, by common sense, what is the derivative of cotangent equal to?
1 over sine x.
Clue. No, but just the answer right away.
It'd be 1 over secant squared x.
Well, that one was secant, so this one has to be cosecant. So negative cosecant squared x. This is the wonderful part about these trig derivatives, because if you know half, you know the other half, because they look exactly the same with completely opposite functions. Okay. So you have the derivative of tangent is secant squared, the derivative of cotangent is negative cosecant squared. So that's cool. All right, finally, we are there to compute the derivative of secant x. And secant can be rewritten as?
1 over cosine.
Yes. 1 over cosine. And what rule can we use? Quotient rule. All right, go. You know the quotient rule from last class. So you should be able to work this out. Yep. Okay, so if you are to use quotient rule here, you will have the cosine squared x in the denominator, then you will have a cosine x times 0, because the derivative of the numerator is 0, minus 1 times, and then you have negative sine x. So the whole thing simplifies into just sine x divided by cosine squared x. You separate these into 1 over cosine x times sine x over cosine x to get secant x tangent x, which gives us a formula. The derivative of secant x is secant x tangent x, and then we put the cloud. So now with that, what is the derivative of cosecant? Yes, negative cosecant x cotangent x. So you have 3 of these are positive, 3 are negative, and the ones that are right, all of these pairs are obtained through the same calculation up there. That's not a proof, it's just a calculation. So you can do it, right? Lab, exam, final exam, it's just a calculation. Now, the modified formula will still go the same way. The derivative of secant ax is going to be a secant ax tangent ax. So if you have that a in front of x, any number, right, it will go in front, and then secant gets its a, tangent has its a in the answer, so all of those would stay. Good. So now we know all 6 trigonometric formulas, and finally we can do some cool derivatives, right? One of those derivatives is for pendulum, like this. So we can figure out the velocity, distance, acceleration by taking these derivatives. Before we get there, let's do 1 or 2 of the vanilla cases and then deal with this. So what is the derivative of x squared times cosecant 3x? What kind of rule do we get to use? Very good, product rule. There is x squared multiplying cosecant, so we get to use the product rule here. And then be careful with that 3x, right? So you have to use the a rule for the cosecant. So for product rule, we copy x squared and take the derivative of the cosecant 3x, which is going to be negative 3 cosecant 3x cotangent 3x, and then plus copy cosecant 3x and multiply by the derivative of the first, which is 2x. Now, what I said on Monday is that every time when you do the product rule, quotient rule, you are supposed to simplify as much as possible because chapter 4 is coming up. And in chapter 4, this is just the first step. You set it equal to 0, and then there is another 30 minutes of the problem. So we can kick out an x, and we can kick out cosecant 3x, which leaves us with, now see the first term is negative, so I'm going to write that one second. So from the first term I took x, so only 2 stays from the second term, only 2, and it's positive 2. So cosecant is out and x is out, so only 2 stays in the second term. And now I go minus, and from the first term I have 3x cotangent. 3x, and that would be the simplified version. From which point on you go and you set each one of these terms equal to 0, and then find values of x, and have fun with that.
Don't sound enthusiastic about that part.
I'm sorry?
You don't sound enthusiastic about this.
Oh, it's just a mess. I mean, you set it equal to 0, you have x equals 0, cosecant equals 0, and then the whole parenthesis equal to 0. It's just mess. It's not, it's not impossible. You get x equals 0. The second one has no solution. The third one is maybe no solution as well. It's all fun. But it's chapter 4. So we want to practice now just factoring so we don't have to deal with that, right? When we get there. Let's do another one of these fun. Tangent 4x divided by, let's say, secant 4x. Because we can. So what do we use?